This video covers Trig Notes 2.5 and Pre-Calc Notes 5.5. What we're going to be doing in this section is dealing with multiple angles, product sum formulas, and we're going to be using our formula sheet quite a bit here. So I wanted to start out by just taking a look at the formula sheet and talking about showing you where you're going to find the information that we're going to be using. We're going to be talking about double angle formulas today, power reducing formulas, sum to product formulas, product to sum. We don't use those very often, but we may occasionally use those. And then also at the very bottom here is your half angle formulas. So those are going to be the areas that we should be looking at for today. So we're kind of looking at the second column and the very bottom. So keep that in mind as I'm pulling information off of the formula sheet. That's where I'm getting it from. So our first example asks us to find the zeros of this function. So if it says to find the zero, it means that you're going to set the equation equal to 0. So I've written it again for you down here. And what I'm noticing about this problem now is that I've got a cosine of 2x. We haven't normally seen that. What we normally have seen is cosine of x or cosine of x squared. So if you have a 2x here, that means it's a double angle. That means we're going to have to use a double angle formula, and so I've taken from the formula sheet the double angle formulas. Now specifically we're dealing with the cosine. You'll notice that there is actually 3 different cosine double angle formulas. There's cosine squared minus sine squared. There's 2 cosine squared minus 1. And then there's 1 minus 2 sine squared of u. You have to pick which one you're going to use. Obviously we're not going to use all 3 of them. Because my problem over here has cosines, only cosines in it, I want to pick the one that only has cosines in it. So I'm going to use that one. So my first step is to basically just replace, again I'm just using the formula as a substitution, replace cosine of 2x with 2 cosine squared of x minus 1. Now I know the formula has a u here, but you can put any variable in there for the angle. In this case we were using an x. Let me write that a little bit neater. 2 cosine squared x minus 1. Then just bring down the rest of your problem. Next thing I'm going to do is just reorganize this. I'm going to reorganize it to say that it's 2 cosine squared x, then minus the cosine of x, and then minus 1. That way I can look at this as a degree 2 polynomial that I want to factor. To make your life a little bit easier, if we took the cosines out, let's just use n for example. If we say that n is equal to cosine, this would be, instead of 2 cosine squared, it would be 2n squared. And instead of minus cosine, it would be minus n. And now you can actually factor this using either the box method or any other of your factoring techniques that you know, which would be what multiplies to be negative 2 and adds to be negative 1. And that would end up being a 2 and a 1, where the 2 is negative. And so we'd come over here, we make our box. And in the first part of the box, you'd put the 2n squared. In the last part of the box, you'd put the negative 1. And then in these two parts, you'd put the negative 2n and the positive 1. And you pull out your greatest common factors. n, negative 1, 2n, positive 1. So what we're really saying is that 2n plus 1 times n minus 1 is equal to 0. If you were to set these individually equal to 0, you would have to subtract 1 and divide by 2. You'd get negative 1/2. Subtract 1, you'd get positive 1. But remember, we made this substitution that n was the same as cosine. So now let's replace n with the cosine of x. And over here do the same. So now we need to go to our unit circle and find the angles that have a cosine of 1/2. And one thing I didn't mention, and it's worth mentioning now since we're dealing with actually finding the answers, is we had a domain up here. Our domain says that it has to be in radians, and it's between 0 and 2 pi, but not equal to 2 pi. So I want one time around the unit circle. If 2 pi ends up working, I can't include it as part of my answer. So I'm looking at my unit circle. All of the angles that have, I wrote it down as 1/2 here, but I noticed that it's negative 1/2. Negative 1/2 as the cosine. All the angles that have negative 1/2 as a cosine is 2 pi over 3 and 4 pi over 3. all of the angles that have 1 as the cosine is 0 pi and then 2 pi, but again, it can't be equal to 2 pi. So we would cross that off. And so we would have 3 answers. Now, as always, we'd want to take the time to plug these answers in to here, into the calculator in radian mode, and check to make sure they verify that all of them are equal to 0 when you plug them in. And they would be, as long as you insert your parentheses in there correctly. Okay, taking a look at this next problem, we'll notice that we have our domain here is in radians again, so we want our answer to be in radians. Finding the zeros means we're going to set our problem equal to 0. And then what I notice is I have a 4t and a 2t. So what I'm going to have to do, since I don't have a 4 times an angle, I only have a double angle, or 2 times the angle, I'm going to have to make a substitution. So right away what I'm going to do is I'm going to make the substitution that n is going to be equal to 2t. Because I could really write this 4t as 2 times 2t. And so now I can go through and I can replace, here I can replace it as saying, instead of sine of 4t, I could write it as 2 times 2t, which we said was what n is. And then this would be 2 sine of 2t is the same as n. Okay, so now looking at this problem, now I've got the sine of a double angle. So I'm going to use my double angle formula over here. So I'm going to replace the sine of 2n to be 2 sine of n cosine of n, and I'm just going to bring the rest of the problem down, plus 2 sine of n. Now, looking at this, I'm going to ask myself, how do I solve this? Well, the only way I'm going to be able to solve this is if I pull out the greatest common factor. And I know the greatest common factor, they both have a sine of n in common. Actually, they have 2 sine of n in common. So if I take out that 2 sine of n, when I take it away from here, I'll have just a cosine of n left. And when I take it away from here, I'll have just a 1 left over. Okay, at this point in time, what I'm going to do now is I'm going to go back and recognize that wherever I see an n, remember that n is really standing for a 2t. So I'm going to make that substitution now again. I'm going to go back and I'm going to plug in an n equals 2t. So that would look like this. 2 times the sine of 2t, then parenthesis, cosine of 2t plus 1. Because now by doing that, what I'm noticing is that I have another double angle right here. So I'm going to change this by using my double angle formula to 2 times, so drop down that 2 sine of t cosine of t. Okay? Now at the same time, here I have another double angle, but this time it's the cosine. And I don't have the formula on the sheet here, but the formula for cosine of 2t that I'm going to end up using is going to be 2 cosine squared t minus 1. So I'm going to change cosine of 2t to 2 cosine squared t minus 1. Again, I'm finding that off of the formula sheet. So if you're curious on how I got that, that was from the formula sheet. Then don't forget to add this 1 to the end there. Okay, so I know these will end up canceling out from each other. And now what I have is 2 times 2 sine cosine 2 cosine squared t. That's all being multiplied together. So I can actually multiply that together by saying that this is going to be 2 times 2 times 2 is 8. I only have 1 sine here. And cosine times cosine squared gives me cosine to the third of t. And again, this is still equal to 0. So if I'm going to solve this, I want to get rid of the 8. So I'll divide by 8. So 0 is equal to the sine of t cosine cubed of t. Now normally when we have two things, like up here, when we have two things that are being multiplied together, individually we can set them equal to 0. Well, that's exactly what I have here. I just didn't put parentheses. So parentheses make it easier for you to recognize this. Set these both individually equal to 0. So if I do that, sine of t equals 0, and then cosine cubed of t equals 0. So I want to find the angles that have a sine of 0. So if I go to my unit circle, again in radians, sine of 0 would be 0 pi and pi. 2 pi also has a sine of 0, but I can't include it. Here I have to solve first. Take the third root of 0, so cosine of t equals 0. So I'm looking for the angles that have a cosine now of 0. So go to your unit circle, looking for the x values of 0 would be pi over 2 and 3 pi over 2. Again, take the time to take these 4 answers, plug them in radian mode in the calculator, do sine of 4 times 0 pi plus 2 sine of 2 times 0 pi, and you should get them all to show that they equal 0. Alright, the next one says, given that that tangent of u is equal to 1/2, and that u, which is my angle, is in between pi and 3 pi over 2, pi, 3 pi over 2, that means I'm in the third quadrant. So what I'd like to do is draw myself a reference triangle in the third quadrant. And I want to calculate the sine of 2u. So if I want to find the sine of 2u, I'll do that one first. I'm going to use the formula 2 sine of u cosine of u. So I've used the formula right here. Now, in order for me to do this, I need to know what the sine and the cosine of this triangle is. Well, the tangent of the triangle, which is opposite over adjacent, would be opposite from this angle would be 1. Adjacent for this angle would be 2. But in the third quadrant, remember that my x and my y values would both be negative. And then if I want to know the sine is opposite over hypotenuse. I need to know this side of the triangle. I need to know the hypotenuse. So negative 2 squared plus negative 1 squared equals c squared. That would be 5. So we would say that the hypotenuse would be the square root of 5. So if I'm going to do 2 times the sine of u, I'm going to say that the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And now I've got to multiply these together. So really what I have is a fraction times a non-fraction. So let's make it be a fraction. Now multiply all your numerators together. 2 times negative 1 times negative 2, positive 4. And 1 times the square root of 5 times the square root of 5, well I know square root of 5 times square root of 5 is 5, times 1 is 5. So I'd find that the sine of 2u is 4/5. So the only way that I can find the sine of 2u is to use the double angle formula here and replace it, and then use the fact that I can find the sine and the cosine if I have the right triangle. So let's do the same concept with now the cosine of 2u. So this is really 2 separate problems. Find the sine and the cosine of 2u. So to find the cosine, pick the formula that you want to use. Doesn't matter. I would try to pick one that has only one trig identity in it. So I'll use the last one here. I'll use this form of the formula. So it says do 1 minus 2 sine squared of u. So 1 minus 2. The sine of u would be negative 1 over the square root of 5, but then I have to square that because that's sine squared. So 1 minus 2. If I square this, I get 1/5. 1 minus 2 times 1/5 is 2/5, and 1 minus 2/5 ends up giving me 3/5. So I can find the sine of 2u and the cosine of 2u by using these double angle formulas if I know which quadrant my triangle is in, and I can draw that reference triangle, because then I can find the sine, cosine, and tangent of that triangle to plug into the formulas. Because you'll notice in all of these formulas, that's what I need to know. I need to know either the sine, the cosine, or the tangent. And the other reason it's important is you want to make sure that you get your sine values correct in the third quadrant. Even though these are both positive numbers here, they're negative here. And so that's going to be important that you get the sign values correct.